As part of this tutorial, we will be discussing about text mining and the use of clustering when it comes to text mining. This representation that you see here is called as a word cloud. And towards the end of this logical concept, you would be able to generate a similar kind of word cloud on R. We'll be using R to generate a similar kind of word cloud. And I've also included a case study, or rather two case studies, which would explain about the application of text mining. And out of those two, one concept would explain about the application of clustering when it comes to text mining. Of course, we also have to discuss about natural language processing, which is a step ahead of your text mining. And we'll be discussing about natural language processing probably in the next tutorial after this. So let us get started. Why do we have this text mining? What is the logic? What is the rationale? If you see here, 20% of the data is structured and 80% of the data which is getting generated in the current world is unstructured. And out of this unstructured data, majority of the data is textual in format. Of course, video is fast catching up. The amount of unstructured data through video is fast catching the attention of the world. However, we will restrict to unstructured data, which is textual in format. Your call transcripts. If you call a call center, you would receive or you would hear a message upfront which says your call would be recorded for quality purpose. So what normally happens is these calls are translated to call transcripts, which is textual in format. And they're going to look at your call transcripts and make sense out of that on how many mistakes are there, which are grammatical in nature, so on and so forth. Emails that you send to customer service, those are textual in format. Social media outreach, Facebook comments, Twitter tweets, Google Plus, so on and so forth, it generates a lot of textual data. Speech transcripts is textual in data. Your field agents and the salespeople capture a lot of data which is textual in format once again. And the most important thing from data collection perspective is interviews and surveys. Right? We do a lot of interviews, we conduct a lot of surveys in the hope of collecting data. Now, all this is textual in format. How do we analyze this data? That is the crux of text mining. So let us now understand bag of words representation, which is extremely related to your text mining. What happens even before text mining happens, right? So if you look at this, here is a package from Shakespeare's, one of his plays, one of his writings. An English professor would say, wow, such a nice scripture, right? Such a nice English literature. That is what your English professor would say. All the world's a stage, and all the men and women merely players. They have their exits and their entrances. And one man in his time plays many parts. This is what Shakespeare has written. An English professor would go on and on explaining about these three lines for hours together. But for a statistician, they would look at this passage in this way. A statistician would say, no matter who has written this, world is used once, stage is used once, the word men is used once or twice rather, women is used once, play is used twice, exit is used once, entrance and time are used. If you're wondering on what has happened to this word all, or the whenever you do any analysis, you'd be interested in specific words which are very relevant, right? All, the, a, apostrophe, comma, and all these are used in almost all the literature, and these words do not make any sense. Hence, we will exclude that and only we are going to consider the key terms. Also, if you notice here, men is used twice. It's not men and women because women is also used once. Men is used twice in the sense we have men here and we have man here. This is singular, this is plural. But both mean the same. Both are referring to some gender. Both mean the same. Hence, you have only one word which is men and we have two against that. Play. If you look at this, we have players and we have plays. Now for these two words, the stem word is play. What does that mean? If you have the word play, you can add a lot of extensions to this, such as play. If I add ed, it will become played. If I add ers, it will become players. If you just add an s, it's called as plays, so on and so forth. Exit, this word is used once. Entrance is used once. Time is used once, so on and so forth. And this kind of a representation is called as bag of words representation. Now there is some terminology that we need to understand, right? And there is some pre-processing that we need to perform upfront. First thing, let us understand the terminology here. Each row in a document, if you have a document full of collection of text, each row in that document is called as a row, right? And even an empty row is considered as a document, right? Even if you have an empty row, it is called as a document. Collection of all these documents is called as corpus. Yep. Document. Each row is a document. Each review written on Amazon or Flipkart or Snapdeal, when you purchase a product, you tend to leave a feedback, right? So each review is a document. Collection of all those reviews is called as corpus. Of course, we need to understand the quirks of languages. Someone might mistype, right? Someone might, type it in this way instead of music. So there's a typo here. Someone has typed everything in, or a few words are in lowercase, a few of them are in proper case, and a few might be in uppercase. We need to bring everything to a common case, either all proper case or all lowercase or all uppercase. And these kind of punctuation marks or special symbols do not add any value to us, right? Percentage, exclamation, ampersand, all these you need not have, right, in your analysis because it doesn't really make sense. Filler words, connectors, pronouns, such as all, for, of, my, to, so on and so forth. All these are not required for our analysis. And also on this corpus, we need to perform stemming. What does stemming mean? If you have two words such as jumping and jump, the stem word here is jump. So you would consider only that word for your analysis. Now, in order to explain this further, I would show you Amazon customer reviews of Xbox 360 because I have a case study pertaining to that. So when you do a Google search and search for Amazon or search on Amazon for Xbox 360 reviews, you'll find these. So this is a review written by one person. This is a second review. This is a third review. Fourth review, someone has written a lengthy one. Fifth review, sixth, seventh, eighth, so on and so forth. Right? You have a lot of reviews written in one page. Imagine you having 138 pages of such reviews written. And if I ask you this, on what are the positive features which people are speaking about Xbox 360 console, and what are the negative features which they are speaking about? Would you read each and every line and then try to make sense? Absolutely no. That would be an overkill. That would be so cumbersome, right? So if you look at this here, we are not interested in, see, we want to know what are the positive features and what are the negative features which people are speaking about Xbox. Why do we need to know that? I'll tell you in a moment. So you want to know that. So it's not a feature. So I really don't want that. So I really don't want that word. The, comma, right? I don't want all these things. And if you want more, I'm interested in features. So I don't want all these words, which doesn't really make sense. Someone might have written something incorrectly, right? Spelling mistakes can always creep in. So your system, we'll be using R. Your R statistical tools should be in a position to understand what is a mistake in a, or what is a spelling mistake, right? And if you have something which is written in uppercase, lowercase, proper case. Proper case means start of the word would be in caps and the rest will be in small, right? That's proper case. So if you have data in this format, you have to bring this data into a common format first and then try to analyze. And we need to look at the stemming also. Do I have any to show you stemming here on whether I can give you an indication on stemming? Probably games, okay. Oh yeah, here we have playing, right? If you have play somewhere, let me do a, there we go. Here we have a word called play, or is that the same word? No, it's a different word. Here you have a word play, here you have playing, so on and so forth, right? Here we have a word called player. So all these things can be stemmed into a word called play. So whenever we have such stop words, we need to ensure that we remove those. For example, you have you, can, find, so on and so forth. We need to remove those. All right, this is how we actually end up doing some kind of pre-processing on the data. Now let me go back. Now what do? You extract all the data from any of the source that you like. Here we'll be using R to extract the Amazon reviews, right? And once the reviews are extracted, you place it in a text document and then you start off with your analysis. Say you have 100 document corpus. When I say 100 documents, say you have 100 reviews which are extracted from Amazon pertaining to Xbox 360. Once all the cleansing is done, you need to represent the data in DTM format, document term matrix, or term document matrix format. What is document term matrix? Each document that you have, or each review that is written is a document. And in the first review, say the person has referred to this keyword called keyboard 4 times. Maybe this person has referred to USB once. Maybe this person has referred to the word free none of the times. The word hard is referred to twice, so on and so forth. In the second review, another person is referring to keyboard 3 times, USB once, the word free is referred to once, and the word hard is used none of the times. So on and so forth. Say you have all the documents available and you have the count, right, on how many times each word has been used in the document. If you count how many times each word is used, you'll get overall 200. So that means the word keyboard has been used 200 times in 100 reviews, right? It has been used 200 times in 100 reviews. So on an average, it is being referred to 2 times. And there is a word called USB, which is referred to 50 times in the 100 reviews. But on an average, How many times is it being referred to in each review? 0.5 times. How did you get that? 50 upon 100 documents. This word free is appearing 100 times in 100 reviews. So on an average, it's appearing one time in each review. So on and so forth, you'll have the data. And this is called as term frequency. How many times a specific term is appearing. That is called as a simple term frequency. It's a regular term count, right? If you randomly count how many times a specific word has been used, that's called as term frequency. And I'll come to term frequency inverse document frequency. If you represent your documents as records or row values, and if you represent the terms in the columns, then this kind of a representation is called as document term matrix. If you reverse this order, if you have terms on your rows and if you have documents as your columns, then that would be called as term document matrix. That is the difference between document term matrix and term document matrix. Now, there is a drawback associated with term frequency, and that is, what if this first person has referred to the word keyboard 50 times? So this first person has referred to the word keyboard 50 times. So the overall count also would increase drastically, and when you take the average, it is going to be higher number. And it is going to be a higher number because of only one review written, because of only one person referring to the word keyboard, say 54 times. So I need to increase this by 50, and this term frequency will get increased to 2.5 on an average, because it's 250 by 100, you'll get 2.5. So 0.5 is a huge increment when it comes to the term frequency. And this is getting increased only because of a single person who was completely bent upon the word keyboard. Probably he had to speak only about keyboard, nothing else, so he has referred to that 54 times. Just because of one person, you should not consider this value, because if you do so, you're giving more importance to one person, but that is not our intention. We want to do a review of all the reviews. We need to review all the reviews and then determine which word is more important. That is our intention. Our intention is not to look into only one person's review and then comment on that. Hence, to solve this problem, we need to kind of normalize the effect of these kind of extreme values. Hence, we are going to use another concept called as term frequency inverse document frequency. So what we do is, this is your document frequency 2, and inverse of this would be 1 by 2. And you're going to multiply each and every word by 1 by 2, by 1 by 2, by 1 by 2, so on and so forth. Now look at what happens, Initially, the difference before normalizing, the difference between 4 and 3 would be 1. Now, if I do this normalization, 4 by 2 would be 2, 3 by 2 would be 1.5. So now the difference between these two is 0.5. So we have successfully brought down the difference between different terms. This is how we try to normalize the effect of one person using a word maximum times in a specific review. That is term frequency inverse document frequency. We look into the importance of each word vis-a-vis the entire corpus. Yeah, that is exactly what we're trying to do. So those are the terminologies that you need to be aware of. Now, once we have either DTM, document term matrix, or term document matrix format, we need to generate word cloud. We would do this in R. So this is called as corpus level word cloud. What do you mean by corpus level word cloud? I'm using all the documents. Collection of all the documents is called as a corpus. And we're using all those documents and then generating this kind of a word cloud. And this is based on term frequency. The word cloud is based on term frequency. That means bigger the word, maximum times it has been used in your reviews. So game has been used or referred to maximum times. Then we have music. So probably Xbox is used to play a lot of music. Probably there is a USB which is helping a lot. You can probably watch even Netflix movies or series on Xbox. And it's a gaming, a device. And this way you can generate a corpus level word cloud. But the drawback with this corpus level word cloud is that you are considering all the reviews as the same. Now think in this way. Reviews could be written by a person who is pretty young, maybe 12 years old. Reviews can also be written by a person who is 32 years old. Probably this person has purchased Xbox for his kid and he wants to leave a review. Maybe grandparent has purchased Xbox to give it to his grandson, or maybe he wants to play, he or she wants to play. 64 years person also might want to provide a customer review after purchasing Xbox. So all of these people can leave reviews, and these people can be of various genders. They can be located in different geographies. Their buying behavior might be different. How can we say that all of these people are the same, combine all of these, and then generate a corpus level word cloud? Instead, we need to do a clustering here. We need to cluster based on gender, based on age group, based on geography, so on and so forth. And then for each cluster, generate a word cloud. Maybe you'll come up with, say you have 100 reviews. Out of these, maybe when you do clustering, it might so happen that 25 reviews might be related to a cluster group of related people who are school going. Now you want to know what features the school going people are majorly discussing about. That makes sense. Maybe another 25 people are into some kind of gaming competition. So all these people are into maybe gaming industry, right? Maybe there are another 25 people who actually build new gaming applications. They're also using this maybe. So all these people belong to different groups. You cannot say that all these 100 people, school going, gaming industry, everyone is the same. If you assume everyone is the same, then you tend to generate a corpus level word cloud, which might be wrong. At the same time, your Xbox manufacturers might be interested to know on what are the positive features that people are speaking about. And it might so happen that, right, someone, or bigger the word, maximum number of times they're using that. But look at this. If you go and tell your Xbox manufacturer that the word silent is being used maximum times, then probably quieter, then probably your Xbox manufacturers would retain these features in the future releases also. Quiet, maybe stemming isn't done properly here. That is what I sense. And look at this word free. Free does not mean Xbox 360 comes for free. You need to read it in the context. What do you mean by that? What I mean is, you need to search for this word free in the raw document, raw text document, and then read the entire statement and then try to make sense. When we have done that, we have seen that people were speaking about free Xbox Live, right? Now, let me show you what does this mean, reading in context, right? What does this exactly mean? I'll read it in the context and show it to you. So this is what I mean by reading in context. Search for that word and you need to read it in the context. If you see, there are a lot of places where the word free is used. Look at this. 7 GB of free cloud storage. Here also someone is speaking about 7 GB of free cloud storage. Here also someone is speaking about 7 gigs of free storage. Now this is what people are interested in. The word free is giving you a sense that you need to go and search for this word free in context and then try to understand on in what context this is being used, right? Rather than reading thousands of pages of reviews, this is a much better exercise. Now at the same time, your Xbox manufacturers would also say, hey, what are the negative features which people are speaking about? And if you provide this information to Xbox manufacturers, probably they'll try to rectify these in the next version of Xbox. Look at this, the word hard is standing out. Someone has used this word hard maximum times, or not someone. In the given reviews, the word hard is appearing maximum times. And when we have read it in the context, we found that the gaming console keyboard, the keys were very hard. Now this information will help me come up with a better version of Xbox moving forward. And that is going to give me market edge, right? And this is how we do analysis. I'm now going to explain you all about another case study wherein clustering also can be used along with your text. And when I've done this word cloud, this called as a unigram. Unigram means you try to come up with the word cloud which has a single word. Look at these, right? Now, if you look at this, the word accrual, terminated, enrollment, low, lack, slow, safety, all these are standing out. But I need to read these words in the context to know what are the reasons on why clinical trials are being terminated. And I've coupled this with Dendrogram. And you know that if two words are close to each other, those two are being used together. So if you look at this, the word enrollment and accrual are connected, right? So these two form a cluster. So these two are very close. So these two words are being used together. And these two words are connected to another word called slow. So slow enrollment, slow accrual. These might be the reasons why studies are being terminated. So by looking at that small cluster of words, this one, you can probably make sense. Yeah, and if you pay a lot of attention, you'll also come to know about various other things. But these are this is how you need to couple your word cloud with Dendrogram and then try to make sense. And that is what is analysis that I've listed here. Keywords which were standing out of the rest are all of these which are highlighted using red border. And these words should be seen in the context to gain business value. But when we see this word in conjunction with Dendrogram, we notice that slow accrual, slow enrollment could be a few reasons. Poor efficacy. Yep, efficacy and poor are related. That could be another reason. You have sponsor and funding, which are used together. So probably sponsor funding could be another broad theme on why clinical trial is getting terminated. Now, what I've done is I've tried to do a bigram. Bigram is doing a word cloud with two words, not with one word. And now it really makes sense. Slow accrual has been used together maximum times, slow enrollment, low enrollment, low accrual, right? If you see here, we have another thing called as safety concerns. These are the words which are catching the attention of the world, or attention of our analysis. And I've coupled this with semantic network. If two words are close to each other, those could be the reasons for your clinical trial being terminated. If you look at this, safety concerns, right? And you have a lot of things here, such as enrollment, recruitment, trial stopped, right? Those could be the business reasons. Insufficient funding could be another reason, maybe. Poor accrual could be another reason, right? So in this way, when you analyze this in context, or you can look at semantic network in bigram and conjunction, you come up with this. In this way, you can generate an n-gram also, trigram, 4 grams, n-gram, based on your business context. But there was an amazing thing here. Your semantic network is saying that safety concerns are reasons for clinical trial being terminated. And you also see that in your bigram, the word safety concerns are used together. But when we have read this in context, when I say context, open all the XML files, do a control F and search for safety concerns. In 100% of the cases, 100, not 99.9, in 100% of the cases, it was no safety concerns. Now, if you did not read this in context, I would have lost this insight, right? And I would have thought that safety concerns could be the reasons for clinical trials being terminated. Look at how amazing, how interesting text analytics could be. It's giving you a lot of information. You can do it for the products. You can extract the tweets from Twitter, right? You can analyze about politicians, about the various products. You can analyze a movie trend. How is it going, positive, negative, so on and so forth. You can extract all the tweets pertaining to Narendra Modi and do a quick analysis and determine on how many people are tweeting negatively about Narendra Modi and how many people are tweeting positively about. And you guys also remember the Nestle Maggi fiasco, right? Someone has told or raised an alarm saying that there is excess lead content in Maggi, which is harmful. And Nestle has faced a huge setback from the noodles perspective. Now it's really difficult, to gain the market back. So if someone analyzed if someone has analyzed social media pertaining to Maggi and Nestle products, maybe they would have got an alarm upfront. If they would have continuously generated these kind of word clouds, they would have upfront come to know on whether there's a negative trend going on. If yes, what are those negative things that people are speaking about Maggi? And Nestle could have avoided such a disaster, right? These are the business scenarios where you can use your text mining, etc. And I have done a corpus level word cloud, meaning I've considered that all the diseases, all the drugs, all the clinical trials which were terminated were the same, which is wrong, right? So we need to again create clusters, groups of related things. Probably all asthma patients, clinical trials are related. All HIV patients, clinical trials are related. So you can probably perform a word cloud on this separately and on this separately. That would give you better results. You could probably do better analysis then. Right? Hence, what I've done is I've used Scree plot. In the previous tutorial, we have discussed about k-means clustering in the Scree plot. Here I see a steep bend at 4. So when I've generated 4 clusters were not giving me meaningful insights, meaningful information. Hence, I have seen another bend here, but you normally do not end up taking 2 clusters. But still, I just tried out. And I've tried to generate 2 clusters. And when I've generated 2 clusters, I've got some meaningful insights. If you look at this, this is my first cluster. And this first cluster is majorly speaking about accrual. When I've evaluated the Unigram single word cloud, along with cluster Dendrogram, I felt that majority of these are pertaining to accrual. Look at this: accrual due to enrollment, accrual due to slow, the standing out. Hence, right? And what is accrual? Accrual is a term referring to the number of patients in a study or clinical trial. So this Dendrogram and that word cloud has given me an indication that this is all about your accrual. And And when I've analyzed for the second cluster, I felt that this is speaking majorly about early and premature termination. And probably I'll give this a name called early and premature termination, right? And if you notice this clearly, look at this, prematurely something got closed, right? So in this way, if you analyze this, probably you'll get a sense on why clinical trials were terminated pertaining to this cluster. Hope you got better insights from this case study. Now let us do practicals using R. Here is a practical case study on generating word clouds, dendrograms, semantic networks, so on and so forth. The focus here would not be on explaining each and every line of code. The code would be uploaded and you can download and try to make use of that. The focus here is in explaining all the concepts, right? Even before you get started, please ensure that you check your Java version and download the latest version. You can, I would say, if you were to play safe, download both Java 32-bit and 64-bit if you don't know how to check your Java version on your system. Right? So you need to install all these packages to be able to come up with the analysis that I'm going to show you now. These are 8 packages. What is a package? A package is a collection of code, collection of functions, right? Which are written by people and which are made available to us. And we need not reinvent the wheel. We need not write the code once again from the scratch. We can just start making use of this. So after you install this, you need to invoke, let me invoke in C. Yep. So I have upfront, I think, some time back, installed this package on this computer. TMS text mining, then you have Snowball C, word cloud, which has a dependency package R Brewer. You have RWeka. It says there is no package called RWeka, so I think I need to install it now. Let's see how much time it takes. Hopefully it doesn't give me any error. It's just a matter of 1 minute or so, so let us wait and see. So I've got an error. Rather than troubleshooting that, let me proceed with other packages and let me see whether RWeka is really required or not. So QDAP is a package, text information retrieval, which has dependency packages, iGraph, which will help you come up with your semantic network, and then you have map. Now, I've written a lot of code here, so you guys can simply, run this when I give it to y'all. These are just blocks of modules that I've written. Now here, I want to scan for positive words. So let me search for R crashed. We don't get to see this R crash so frequently. Anyways, I think we need to load this once again. You can select the bunch of code and also run that. That's absolutely fine. I've given comments also against the code, blocks of code, which will give you a sense on why you're doing that. Here, I'm trying to load and give as an input the positive word cloud, positive words. So here are the positive words. I have 2006 positive words. If you just say POS, you have the list of positive words which is available in your English dictionary. And in a similar fashion, you can also provide the list of negative words. So let me select that. Based on these, your system would understand on what are positive, what are negative. You can also provide your bunch of positive and bunch of negative words. So along with this positive word document, you're adding wow, kudos, hooray, etc. to your positive words. If you're generating this for your clinical trials, you need to understand what terminologies are positive and what terminologies are negative in clinical trials. So when you run a line, a function, or a comment, it doesn't really matter. It will not influence your output. So anything which is written after hash is called as a comment. It is written for your own understanding. For example, x equal to read lines, file or choose would give me a pop-up window. So there I'm saying reading data from Amazon, Nokia, Lumia reviews. There's a comment that I've written which will be helpful for anyone who's trying to read this code. Now let me navigate and try to find Amazon, Nokia Lumia reviews. The text document is loaded. What is the length of this? You have 120 in documents. Let us create a corpus. Corpus is collection of documents. We are stripping of the white space, double space. If you have, you're trying to remove that. You're trying to convert everything to a lowercase. We are trying to remove the punctuation marks, numbers. We are trying to remove the stop words of English language. You need not give these. Right, yep. And then I'm converting everything into a plain text document. There is also code written for your ngram. That is, if you keep changing this value, you can generate a 3-word word cloud. And if you want two, it's minimum 2 words, and you can say maximum 2. So that would generate a bigram for you, so on and so forth. So it's hashed out. I don't want to run that now. And we are creating a term document matrix. You know for a fact that term document matrix is inverse of document term matrix. So I've done that. Intention is to show you all the word cloud. And this Windows function will not work in MacBook. It will work in Windows. So let me come up with a word cloud. Yeah, look at that. It's coming up. Ah, come on. Hopefully this time it doesn't crash. Let me quickly run that. That's absolutely fine. I can quickly run it now. There is option to select the code in this way. Let me upload positive words. Done. Let me now try to upload the negative words. Now let me read. Even if you don't run those words which are hashed out, it doesn't really matter. I'll not run this. Instead, I'll run this. So this would generate the word cloud. If you see there is a stop, yep, so it has generated a word cloud for me. I can say this is a Unigram word cloud. We can also generate semantic. I'll not use Windows because it's to just pop up a different window. It works well in Windows, not in Mac. So here is a semantic network. Yep. On what two words are used together. If you want to get a sense of that, you can use this. We can also come up with a cluster dendrogram. There we go. What two words are being used together. This theoretically we have understood. I just want to show you practically. We have written a function for positive word cloud, so you'll see all the positive words there. And you can also give a title to this. In the moment I've given the title, it appears here, Unigram positive word cloud at the bottom right. And you can run a negative word cloud. There we go. Problem, downside, complicated, hard, trouble, break, lacking, freeze. Yeah, all these are the problems. And you can also generate k-means clustering, which I've already shown you yesterday. By looking at this, I feel that 3 clusters might make more sense, or yep, 3 clusters or maybe 4 clusters. So for now, just to show you all, I'm choosing k equal to. And if you want to make a word cloud, yep, there we go. This would generate another cloud. It's still coming up in that way, right? So you can do a bunch of analysis here. The entire code is all about generating the cluster dendrograms, right? Yep, and the code stops there. So I just wanted to quickly show you on what are the possibilities in R. You can come up with dendrograms, you can come up with word clouds, right? You can do a bunch of analysis.